But if you are a judge and if you will asked who is right, then both are right, because A is right from his frame of reference and B is right from his frame of reference, and they will also come to the same conclusion. They are observing and measuring the same point P but with two different frames of reference. That's why they are getting two different numbers. If they can find out the relationship between themselves, and what is that relationship? That relationship is what is the position of B with respect to A, that they must know, and that is what is called X position of B, the frame of B with respect to the frame of reference A. Okay, so this is the this number actually connects both A and B. So how I am going to write it? So I will write it that X position of P with respect to A is equal to position of P with respect to B, position of P with respect to B plus position of B with respect to A. And there is a very nice correlation of writing this thing. There is a beautiful advantage. What is that advantage? You see, normally if your equation is right, then you will get that the subscript of the left hand side is equal to the subscript of the right hand side, because this P by A you are getting just by multiplying P by B with B by A. Look at this. So P by B, and if I multiplied it with B by A, I am getting same thing. So I will conclude that I have written the equations correctly, isn't it? This B get cancelled and you are left with P by A. So this is how you have to represent the relative position of you have to represent the position of a point measured from two different frames of reference who are moving, suppose. And now what will happen? Suppose both of them are at rest, but if one will be moving, how we are going to get? So first we have to find out that if both of them are moving and we want to find out, establish a relationship between the velocities, then how we are going to do? So I will take a derivative of this equation. So I will taking a derivative of this equation. So d x P by A with respect to dt. Now I am taking the time derivative of both the sides of the equations is equal to d x P B, okay, divided by dt plus xBA, that is dxBA dxBA by dt. Okay, and how this is represented? This is represented as velocity, x velocity of P, okay, with respect to A, because it is x velocity, so I have to write A hyphen x. Similarly, so the velocity, the x velocity of P with respect to A is equal to x velocity of P with respect to B, x velocity of P with respect to B. You see how I am, and then plus velocity of x velocity of B with respect to A, x velocity of B with respect to A. Okay, so this is the equation of relative velocity, the equation of relative velocity in one dimension. Okay, this is how I find out my equation from these equations. Okay, now it is very easy to, because now you could write this equation in one dimension. Now you can write this equation in the other dimensions also. Now you see, if you want to express, suppose this velocity of A, if you want to express, then velocity of A, because you have expressed velocity, x velocity of B with respect to A. Suppose you want to find out x velocity of A with respect to B, then that will be the negative of the other one. Okay, so x AB is equal to x velocity of B minus, and it is natural, x velocity of B with respect to A. Okay, so this relationship also holds good. Okay, so this is the another relationships. And then if you want to expand it into 3 dimensions, you can always expand it relative velocity in space, because you have to take the position coordinate. Suppose I want to expand, because we are not going to use it just for intellectual purpose, academic purpose, that is, you can say that because you are now in a position, you know the one dimension, how the relative velocity is represented, and if you are interested to know how the velocity, relative velocity equation will look in 3D space, then you can also write it like this. Just I am writing. So first you have to write that the position coordinate of the position vector R of P with respect to the frame of reference A is equal to position vector of P, position vector of P with respect to B, position vector of B, P with respect to B, plus position vector of B, position vector of B with respect to A. Only I am using vectors, and from here straight away I can get a 3D relationship for relative velocity in space. And what is that? Just I will take a derivative and I can write that the instantaneous velocity of P with respect to A is equal to instantaneous velocity of P with respect to B plus velocity of B with respect to A, and this is what called relative velocity in space. Okay, the earlier one was relative velocity in 1D. Okay, so this is how you can show the relative velocity equation in space. Okay, so I think this is the only physics that one can learn, and all other things, there are so many things to these equations, and these equations that I have shown you are known as Galilean transformation equations. Now these transformation equations are very important because it connects between 2 different frames of reference, isn't it? And that's why it is so important. But you will see that these Galilean transformation equations are inadequate in actual world, or in reality. When situations changes, then Galilean transformation equations do not work. Okay, I hope relative velocity. Now we want to put this relative velocity into test in an example, and let me clear the frame. So let me read out the example first. So that is what is the relative velocity. I have already explained you. Now we'll go to an example. An airplanes, now look at example 3.14, flying in a crosswind. An airplane's compass indicates that it is headed due north. So the aeroplane has a compass, and the compass is indicating that the aeroplane is heading in the north direction, and its indicator shows that it is moving through the air at 240 kilometer per hour. So the aeroplane speed in air with respect to air is 240 kilometer per hour. If there is a the aeroplane speed in air is 240 kilometer per hour, and if there is a 100 kilometer per hour wind from west to east, and there is a wind which is blowing from west to east at a speed of 100 kilometer per hour, what is the velocity of the plane relative to the earth? Okay, if there won't have been any blowing of wind from west to east at the rate of 100 kilometer per hour, then the aeroplane's velocity would have been also 240 kilometer per hour. But what will be its velocity of the plane relative to the earth? In this situation, how I am going to find out the velocity of the plane relative to the earth? So first let me write down the what are given in the problem. Let me write by using the symbols. So first I will use, because it is a problem involving vectors, so I must use these equations. So what is that equation? Now velocity of a point P with respect to A, okay, this I am using, is equal to P with respect to B plus velocity of the point B with respect to A. Okay, so this is the equations I have learned in 3D, and then I will try to figure out a thing. So your aeroplane in the presence of the air, now it is moving in the north directions like this. Okay, this is north, because if you like you can put a air diagram like this also. The direction, this is the north direction and this is the east direction, so the opposite will be west, and the air is flowing at 100 kilometer per hour. So this is the air speed, 100 kilometer per hour. So finally the velocity of the plane with respect to earth will be the resultant of these two vectors. Okay, so this is velocity of wind or velocity of air. So I will write it as velocity of air with respect to earth, with respect to earth. Okay, and this is velocity of plane. So for P means plane, so A means air, E means earth. So velocity of plane with respect to air is 240 kilometer per hour. Okay, north. And our task with respect to earth, this we have to find out. And this is the diagram I have constructed for you. Okay, this I am going to find out both in magnitude and directions. So the magnitude I can find out, and I can also find out the angle. Let me designate the angle as alpha. So let me write what is there. So I was given velocity of plane. P means plane, A means air. Okay, not P means point and A means any arbitrary frame of reference. Now here P means plane and A means air. So velocity of the aeroplane with respect to air is given, and that is 240 kilometer per hour north. 240 kilometer per hour is its magnitude, and north is its direction. 240 kilometer per hour due north. Okay, you can write it like this, due north. Similarly, the wind is blowing from west to east at a speed of 100 kilometer per hour. So that also you have to write. So velocity of air with respect to earth, is equal to 100 kilometer per hour. 100 kilometer per hour. Now if you look at this diagram, we want to find out the hypotenuse, and this is due east because it is blowing from west to east. So this is due east, and our task is to find out velocity of the aeroplane with respect to earth. So according to this question, I have already set up these equations, and you can find out this hypotenuse from the right angle triangle formula. So this Vp, that is velocity of plane with respect to earth, okay, is equal to, I am just finding out the magnitude first. So 240 kilometer per hour square. Okay, this is actually kilometer per hour. Remember, 240 square plus 100 square plus 100 square, okay, square root, and then the unit, kilometer per hour, okay, kilometer per hour. So that is more than 240. So to be sure, if you do the calculation, this will become 260 kilometer per hour. So for a earthbound observer, that means an observer who is standing on the ground, he will see that the plane is not moving in the north with a velocity of 240 kilometer per hour, but the plane is moving by making some angle with the north in the east direction with a speed of 260 kilometer per hour. To exactly know its direction, we have to find out this angle alpha. So tan alpha, if you find out tan alpha, this is the perpendicular, this is the base for this angle. So tan alpha will be 100 by 240. So alpha will be, I am writing here, so alpha is equal to tan inverse 100 by 240. So that will become 5 by 12. So alpha is equal to tan inverse, okay, so 5 by 12, tan inverse 5 by 12, and you will find out, if you do the calculation, then your alpha will be 23 degree. It is 23 degree, 23 degree east from north. So there can be two 23 degree, either 23 degree it can incline towards west or it can incline towards east, but it is inclined towards east. So you have to write that for a person who is standing on the earth, for him the plane is moving with a speed of 260 kilometer per hour, not in the north direction, but in a direction which is 23 degree east of north, 23 degree east of north, or you can also express it as 57 degree, 57 or 67 degree, 67 degree, 67 degree north of east, 67 degree north of east. That also you can say, or you can say 23 degree east of north. This is 67 degree north of east, or you can call it as 23 degree east of north. So the aeroplane speed with respect to earth is 260 kilometer per hour with an angle 23 degree east of north. So this is how we can work out the example. So now I will make a summary of whatever I have told you, then we will do test your understanding, and then I will give you assignment exercises, and then this finishes your chapter 3. Okay, so first we what we did actually, I started with an average velocity vector. Then from the average velocity vector we went to instantaneous velocity vector. Then we started with the average acceleration vector, and from there we moved to instantaneous acceleration vector. Okay, and then I showed you projectile motion, which is a combination of two types of motion, horizontal and vertical motion. Horizontal motion is a motion with constant velocity, and vertical motion is a motion with constant acceleration. And what is that constant acceleration? That is minus g, minus 9.8 meter per second square. It is always vertically downwards. Whether the body is moving up or down, g acceleration in the y-axis is always minus g, that is minus 9.8 meter per second square. And on the basis of the few kinematics equations that we have derived for x motion and y motion, we could find out that the trajectory or the path the projectile will take in air will look like a parabola, or the motion is parabolic. Second, it will reach certain height, maximum height, and that also we can find out because the vertical velocity will be zero at the topmost point. Then there is a time of flight, how much time it will be in air the moment it is launched from a certain point, and again it will return back to the landing point, which is also at the same level at the launching point. And that is what is called the time of flight, which is also equal to sum of the time of ascent plus time of descent. And finally we found out the range, or the maximum distance between the point of launching and the point of landing, or the distance, sorry, the distance between the point of launching and point of landing, or the maximum distance, horizontal distance, the projectile achieves in case of a flight. So, and we took an example, that is 3.7, how a baseball player hits a baseball making an angle 53.1 degree with a velocity, initial velocity of 37 meter per second. And then we found out after 2 minutes what will be its horizontal velocity, what will be its vertical velocity, what will be its x position, what will be its y position. Then we found out the what we found out the maximum distance, the time required to go to the maximum height or attain the maximum height. Then we found out the time of, sorry, the range, okay, by multiplying the horizontal velocity with the time of flight. And we have extensively discussed how when the angle is greater than 50 degree, 45 degree, how you have a bigger vertical component compared to the horizontal component, and how this horizontal component 22.2 meter per second in that particular problem will remain constant, though the projectile throughout the trip of the entire of the projectile, it is not going to change, it will remain that 22.2 meter per second. But the vertical velocity's case is different. Initially it will start with a very big promising magnitude of 29.6 meter per second, but gradually the value diminishes, and at the topmost point it becomes zero. Then it will have a negative value in the sense that its direction will now be reversed, but its magnitude will go on increasing, and finally at the launching point it will have the same vertical velocity what it has during the time of launching, okay, because that is possible, because there is no friction or there is no loss of energy through dissipation or resistance. Now I will show you the different texture understanding before going to the examples part. Okay, so
Sir, nothing audible, sir. Screen is freezed.
ಸ್ಟಾರ್ ಒಪ್ಷನ್ ಲೀಡ್ ಮಾಡ್ತಿದ್ದೆ नेटवर्क प्रॉब्लम ହେଇଥିବ ବୋଧେ ସାରଙ୍କର
तो नंतर होऊन जायचं
I was disconnected for some time,
yes sir
isn't it?
yes sir
Yes. So where actually I left,
Yes, sir.
where you were, where the connectivity was lost, can you say? Anyway, I was actually summarizing whatever I have taught you till now. Now we will be working out on some of the test your understanding. There are 5 test your understanding in this chapter and 4 assignment exercises. You will take a screenshot of the assignment exercises so that you will work it out in your home. And now I will be doing some of the test your understanding. Let us see how many test of understanding we will be able to do. There are 5, so I will start from 1. So the first test of understanding is like this. I am not writing the test of understanding. I will just read out the test of understanding and then do the test of understanding for you. So the first test of understanding is like this. In which of these situations would the average velocity vector v average over an interval be equal to the instantaneous velocity v at the end of the interval? Okay, so actually there are I'm reading out the question and be attentive so that you can answer this question. Okay, so I am reading out the question. Please listen to me. In which of these situations would the average velocity vector v average over an interval be equal to the instantaneous velocity v at the end of the interval? So the question asked is, there are 3 situations and you have to answer in which situations the average velocity vector is equal to the instantaneous velocity vector. Okay, already okay, like this and there are these 3 situations.
The screen is not visible.
The screen is not visible. Okay, just wait. Just wait, because there was this disconnectivity, so the screen, I have to present this screen again. Okay, just wait. Is it visible now? Is this screen visible?
Yes, sir.
Okay, so you have to answer that there are 3 situations in which situation average velocity is going to be equal to instantaneous velocity. Bas, that one. So what are the situations? Bit A body moving along a curved path at constant speed. A body moving along a curved path with constant speed. So what is constant here? The speed is constant, but the direction is not constant, remember. Okay, so v is constant, v is only speed. So this is situation 1, v is constant. Okay, we have to say where v average is equal to instantaneous velocity. So this is case 1. Okay, it is moving like this, but with a constant speed, curved path, continuously direction is changing, but speed is remaining constant. So can we say that average velocity is equal to instantaneous velocity? Now the second part is a body moving along a curved path and speeding off. Now a body is there, here v is also not constant and the direction is also not constant. This is second option. Here both are changing because the body is moving with a higher speed. Okay, so here v is also not constant. The speed is not constant, direction is not constant, and v is actually increasing, isn't it? So v is also not constant. And the third situation, there are how many situations are there? There are 4 situations. I was thinking that there are 3 situations. No, there are 4 situations. The third situation is a body moving along a straight line at constant speed v. Okay, this is a straight line. The speed is constant, direction is constant. V is equal to constant, and this is speed, and direction is also constant because direction is along a straight line. So no question of changing. But here you see, if the velocity is here in this direction, the velocity will be in this direction, then the velocity will be in this direction. So here, but here, if the velocity is in this direction, then the velocity here is also in the same direction, like this. So the direction is also remaining constant. And the fourth point is a body moving along a straight line and speeding off. That means the body is moving along a straight line. So the direction is constant, but v is not constant. This v is not equal to constant. Okay. Now can you say in which case our velocity, average velocity vector and the instantaneous velocity vector will be same out of these 4 cases? Okay. In which case?
Option E.
Yes?
The third case.
Third case.
Third case.
Third case, good, very good. Because in order both of them have to be constant, the magnitude and direction must be constant, which is exhibited in this example. So this is the answer. So this is test your understanding 1. So you see, this test your understanding, actually test your understanding TYU 3.1. Okay, so this is 3.1. Now we'll go to the second one. Okay, so now I'll go to the second part of the test your understanding. Yes, and the second, that is test your I'm again reading out the problem. First you listen to the problem clearly, then I will say you. We will work it out. A sled travels over the crest of a snow-covered hill. The sled slows down as it climbs up one side of the hill and gains speed as it descends on the other side. Okay, which of the vectors from 1 to 9 in the figure correctly shows the direction of the sled's acceleration at the crest? Okay, so something is moving along a snow-clad hill. This is a snow-clad hill. Okay, we'll go very slowly. Okay, this is snow. Why they have taken a snow-clad hill? Because thereby the friction is almost minimized. We can take it as almost like 0. So this is a snow-clad hill. Okay, and while it is climbing up, it is naturally, its speed is slowing down, and while it is descending, its speed is increasing, or it is gaining speed, which is natural. Now we have to, the velocity vectors are shown. What are the velocity vectors? Not velocity vectors, what are the point? Which of the vectors in the figure correctly shows the direction of the sled's acceleration at the crest? There are nine directions of the acceleration. Okay, just beautiful. This is a very beautiful question. One is like this, another is like this, all are of same length, and one is like this, another is like this, then there is one is like this, another is like this. So how many? 3, 3, 6, and then one is like this, and another is like this. Okay, so these are 1, 2, 3, 4, 5, 6, 7. There are name also. This is known as the 1 option, 2 option, 3 option, 4th option, 5th, it is 6th, this is 7, this is 8, and the 9th option is acceleration is equal to 0. The 9th option is acceleration is CL, in short I am writing acceleration is equal to 0. Now did you understand the question? The question is something is moving, some sort of sled or sledge, and it is moving and it has reached its position at the topmost point. Now you have to show the acceleration of that sled by choosing any one of the option, and you have got 9 options. Now tell me which option is correct. Anybody?
The acceleration is equal to 0.
1.
Acceleration is equal to 0. Good. So there are many beautiful. Somebody has told 1. So beautiful. So
Yes,
lot
1,
of
sir.
answers I am getting. Good. Anybody? Others?
Sir, acceleration is equal to the 7th option. 7.
Which one?
7.
7. So the answer is, I have got 3 different answers. 1, 9, and then 7. 1, 9, and 7. Anybody who told 1, can you explain why it is going to be 1?
Because, sir, if a velocity is directed along velocity and acceleration in opposite direction, so the velocity is of topmost point is 0, so it's 1.
Okay. Now you see, now you have to see like this. When the sled, I am just explaining you, though you who has gone for option 1, I am just explaining you. Suppose the person is going up, that means it must have a vertical velocity, otherwise it cannot go up. But its speed is slowing, it is slowing down. So there must be an acceleration which is opposite to it, like this. That's why it is slowing down. So the speed is upward, acceleration is downward, both are opposite to each other. That's why the particle speed goes on decreasing, and when it reaches at the topmost point, it doesn't have any velocity left. So their velocity and the acceleration are exactly same and opposite to each other. So there will not be any velocity. The velocity left will be, so there is no velocity at all. So how this 1 will be its acceleration? If 1 will be, because you see it is not moving in this direction, your sled is not moving in this direction, so that the acceleration will be in this direction. Though the trajectory looks like this, it has a vertical velocity. That's why it is able to move in the vertical direction, because it is gaining height. So how you are going to have a acceleration in this direction? If you would have an acceleration in this direction at this point, then the particle, once it will reach at this point, at the topmost point, then the particle will start moving in this direction, because it has an acceleration because you are telling that it has an acceleration 1. Then once it will reach at this point, instead of coming down, now it will start moving in this direction, but it is not moving. Are you sure? Do you understand my point? Do you understand my point?
Yes, sir.
Once it will reach this point, because its velocity will be 0, but still there is an acceleration in the direction 1, so the particle will start moving in the straight line in this direction, which it is not doing. So 1 is not the answer. Now 9, acceleration is 0. If the acceleration would have been 0, now you who has told 9, I am explaining you why it is not going to be 0. Because if already the vertical velocity is 0, it doesn't have any vertical velocity, and if the acceleration is also 0, then the particle will stay at this point. The particle will stay at this point. It is not going, it will not go in other direction. Okay, it will be at this point. But because the particle it will again move, and why it will move in the negative downward directions also? Because the acceleration is still there. And you know, this whole motion is taking place in a frictionless gravitational field. That's why they have taken this snow covered hill. So as I have mentioned you, that acceleration due to gravity is always present. That's why the acceleration at this point is acceleration due to gravity, and which is acting vertically downwards. So at the high point of the slate's path, the speed is minimum. At that point, the speed is neither increasing nor decreasing, because you have got a plateau region, or you have reached a point of maxima, isn't it? So at that point, the speed is neither increasing nor decreasing, and the parallel component of the acceleration, that is the horizontal component, is 0. Now you don't have any horizontal component because it has reached its minima. The acceleration has only a perpendicular component towards the inside of the slate's curved path. In other words, the acceleration is downward. And I think the acceleration, if it is a completely frictionless snow-covered hill, then the particles must have an acceleration which will be equal to the acceleration due to gravity. 7 will be the answer. Yes, you are right. So 7 will be the answer. Now we will go to test your understanding 3. Maybe we will cover another test your understanding because we don't have much time. No, this 3.3 is a little bit longer, covering a figure. So we will take this 3.3 later on in the next class. Let me find out 3.4. 3.4 is a easier one. Suppose that the particle in a non-uniform circular motion experiences 4 times the acceleration at the bottom of the loop as it does at the top of the loop. That means in a non-uniform vertical circular motion like this, okay, at the bottom you have got a acceleration and you have got a acceleration here. Both are different. A bottom, I can write A bottom is equal to V max. That means V bottom square divided by V square by R, and A top, that is the radial acceleration at the top, is equal to V top square by R. Of course, we need not do this, use this formula. We can do it with our own. Now the question is, suppose that the particle in a non-uniform circular motion experiences 4 times the acceleration at the bottom. Now this AB is 4 times AT. You see, AB is equal to 4 times AT. 4 times AT, isn't it? 4 times AT. That means your VB square is 4 times VT square, or VB square is equal to 4 VT square. So what will be your VB? So VB will be 2 VT naturally, because VB square is equal to 4 VT square. So VB will be 2 VT. That is what probably the question is asking. The question is, compared to its speed at the top of the loop, is its speed at the bottom of the loop root 2 times as great, 2 times as great, 2 root 2 times as great, 4 times as great, or 16 times as great? 2 times as great, because if the speed at the top is x, the speed at the bottom will be 2x. That's why the acceleration will be 4x square here. It will be directly proportional to 4x square, and here it will be directly proportional to x square. That's why the acceleration, because the acceleration is directly proportional to the square of the velocity. That's why if the acceleration has increased by 4 times, that indicates that the velocity must have increased by 2 times. So we have still, so one thing I will do, you just take a, you take this screenshot of these 4 questions. So that will become your assignment exercises. Okay, please take a screenshot of this thing so that we will save time. If you can do it, and if you are unable to do, we can explain along with the two other test your understanding. I will explain these assignment exercises also. Please take a screenshot. Have you taken the screenshot? Yes. Have you taken the screenshot?
Yes, sir.
Yes.
Yes, sir.
Good. Good. So
Yes, sir.
try to do all these 4 assignment exercises. So the 2 test your understanding and these 4 assignment exercises. We will very quickly finish it in the next class, and we will go to Newton's laws of motion or chapter 4. Okay. With these words, let me stop here. So thank you very much for your attention, and we will meet in the next class. Thank you once again. Okay.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.